Hello everybody, welcome to A to Z Learning Hub. Today is our third period in Unit and Dimensions. Today I am giving you one question. What is the dimensional formula of inertia? You know inertia? Inertia means the tendency of a body to remain as it is known as inertia. So, what is the dimensional formula of inertia? You see, inertia of a body is measured by its mass. If a body has more mass, then it has more inertia. So, we can write the dimensional formula of inertia is only m, or we can write m1 L0 T0. Inertia is measured in terms of mass. If a body has more mass, then it has more inertia. Now, question number 2. Angular momentum has same dimensional formula as first bit Planck's constant, second one is universal gas constant, third one is see universal gravitational constant, and your fourth one is your D, that is Joule's constant. You see, which is true? Angular momentum has the same dimensional formula as a dash. You see, angular momentum is equal to linear momentum into radius. What is the dimensional formula of linear momentum? That is m1 L1 t to the power minus 1 into radius as L. That is equal to what? m1 L square t to the power minus 1. It is the dimensional formula of angular momentum. Now, we find the dimensional formula of Planck's constant, universal gas constant, universal gravitational constant, Joule's constant. So, what is the dimensional formula of Planck's constant? You know energy E is equal to hf, or H is equal to energy by F. Energy has a dimension m1 L square t to the power minus 2. Frequency has a dimension t to the power minus 1. m1 L square, that is equal to t to the power minus 1. So, m1 L square t to the power minus 1. So, Planck's constant is your correct answer. These are some questions. Today our topic is application of dimensional analysis. You see, it has three applications. First one is to check the correctness of a relation Second one is to find a relation between different physical quantities. Third one is to convert one system of a unit to other system. These are three applications. First we start to check the correctness of a relation. Here For example 1, F is equal to mv square by r, where F is equal to force, m is equal to mass, v is equal to velocity, and r is equal to radius. In question, F is equal to mv square by r, it is given. Whether this relation is true or not, we have to determine by dimensional analysis. First, what we will do? We find dimension of LHS, then we find dimension of RHS. If LHS, the dimension of LHS is equal to dimension of RHS, then we can say this relation is dimensionally correct. This relation is dimensionally correct. You see, F is equal to mv square by r, this is your LHS, this is your force. What is its dimensional formula? m1 L1 t to the power minus 2. You know it. Then RHS, mv square by r. What is the dimensional formula for mass? That is m, velocity L1 t to the power minus 1 whole to the power 2 by r. R means length. That is your m. This is your L square t to the power minus 2 by L. That is your m1 L square t to the power minus 2 by L, m1 L1 t to the power minus 2. You see, LHS has a dimensions this and RHS. So we can write this relation is dimensionally correct. Next, I am doing another example. You see, number 2, lambda is equal to mv by h, where you know lambda is equal to wavelength, m is equal to mass, v is equal to velocity, and h is equal to Planck's constant. We determine whether this relation is true or false. You see LHS. LHS, it is a wavelength. It has a dimension m0, L1, T0. Then come to RHS. RHS has what? mv by h. Mass has a dimension m. Velocity has a dimension L1 t to the power minus 1. Next come to your Planck's constant. You know Planck's constant is equal to energy by frequency, means h is equal to energy by frequency means m1 L square t to the power minus 2 by t to the power minus 1. Frequency has a dimension t to the power minus 1. That is equal to m1 L square t to the power minus 1. You put it, your m1 L square t to the power minus 1, m1 L1 t to the power minus 1 by m1 L square t to the power minus 1. That is equal to what? 1 by L, that is equal to L to the power minus 1. You can write m0 L to the power minus 1 T0, but LHS has a dimension m0 L1 T0, it has m0 L to the power minus 1 T0. So LHS is not equal to RHS. So this relation is dimensionally wrong. Next, I am doing another example, time period. Time period is equal to T is equal to root over of L by G. Whether this relation is true or false. T is what? Question number 3. Time period, L is your length, G acceleration due to gravity. That means it is one type of acceleration. So whether it is right or wrong, you know LHS. This is the time period, means time M0, L0, T1. Next come to your RHS. RHS is what? Root over of L by G, that is equal to L has a dimension L and acceleration has a dimension L1 t to the power minus 2, then that is equal to the root over of t to the power minus 2. T to the power 2, because here t to the power minus 2, it will go to upper side, that is equal to t to the power 2, and when we take it square root, that is your t. You see, or we can write M0, L0, T1. So LHS is equal to RHS, they have the same dimension, so it is dimensionally correct, this relation. Next, question number 4, you see S is equal to UT plus half AT square. You know this relation, you know this is true, but we test it whether it is true or false dimensionally. Where S is what? Distance or displacement. U is what? Initial velocity. T is time. A is acceleration. You see LHS. Here it is your S, displacement. Its dimensional formula is M0, L1, T0. Now you come to RHS. UT plus half AT square. What is the dimensional formula of initial velocity or velocity? L1 t to the power minus 1 into t, time, plus half has no dimension because it is a constant, non-dimensional constant. Your acceleration L1 t to the power minus 2 into t square, that is equal to what? This is your L1 plus L1. You see, L1 plus L1, that means this term is length and this term is length. So the resultant is length, but you don't write length plus length is equal to 2 length. So L plus L or L minus L don't write 0. You write length plus length. When length is added with length, we get length. Similarly, when length is subtracted from length, we also get length. So in case of addition and subtraction, you don't write, suppose 3 lengths are added, we don't write 3 length. You write just length plus length is equal to length. So you can write also it M0, L1, T0. So LHS and RHS has the same dimension, so it is dimensionally correct. But you see, here you omit half. It is dimensionally correct. I have not considered half. We just find the dimension of LHS and RHS, so we write, so it is dimensionally correct. Next come to your question number 5, that is your what? V square minus U square is equal to 2S. What is V? V is your final velocity. U is your initial velocity. A is your acceleration. S is distance. So whether it is true or false dimensionally, we check. First you see LHS, V square minus U square. You see velocity square, that is your L1 t to the power minus 1 square, minus, here is also L1 t to the power minus 1 square, that is your what? L square t to the power minus 2 minus L square t to the power minus 2. Here you remember, you don't write 0. This is the velocity square minus velocity square. Resultant is also velocity square. So we write L square t to the power minus 2, that is your M0 L square t to the power minus 2. It is LHS. You see RHS. RHS is what? 2S. You know 2 is a constant, it has no dimension. Your acceleration has a dimension L1 t to the power minus 2 into your L. S is your distance, that is your L square t to the power minus 2, that is equal to m0 L square t to the power minus 2. So here LHS and RHS has the same dimension. So this relation is dimensionally correct. Another question, your frequency you write f is equal to 1 by 12 root over of t by m, where f is what? Frequency, L is your length, T is your what? Tension. Tension means it is one type of force, and m is what? Mass per unit length. It is not mass per unit length. That means m is equal to mass by length. So we find LHS frequency as a dimension m0 L0 t to the power minus 1. Next come to your RHS, 1 by 2L root over of t by m. 1 by 2 has a no dimension, you just write L as a dimension 1 by L into root over of tension. Tension means force, which has dimension m1 L1 t to the power minus 2 divided by, this is not mass, you remember, this is mass per unit length, that is your what? m1 L to the power minus 1, you write 1 by L, capital L, just dimension you write, that is equal to what? L square, cancel, L square t to the power m1 L square t to the power minus 2 by mass per unit length m1 L to the power minus 2, that is equal to m1 L, you write L square t to the power minus 2. You just write, because cancel, L to the power minus 1 goes to upper side, that is L to the power 2 into t to the power minus 2, that is your 1 by L. When root over is removed, we can write L1 t to the power minus 1, your what? L cancel, that is equal to t to the power minus 1, that is your m0 L0 t to the power minus 1. So LHS and RHS has same dimensional formula, so this relation is dimensionally correct. So this is the first application to check the correctness of a relation. Next come to your another second application to find relation between different physical quantities. Suppose I am giving one question, the centripetal force of a body, that is F, moving in a circular path depends upon its mass m, velocity v, and a radius of a circular path r. Then find the relation of F with m, v and r by dimensional analysis. How we do it? You see this problem. You take, this is a circle, this is the center, this is the radius, this is the O. Suppose here a body is moving in the circular path whose mass is m, moving with a velocity v. When a body moves in a circular path, you remember a force acts from body along the radius towards the center. Again you see, when a body moves in a circular path with a certain velocity, then a force acts from the body along the radius towards the center, which is known as centripetal force. According to question, the centripetal force F of the body depends upon mass of the body, velocity of the body, and a radius of the circular path. We find relation of F with M, V, and R by a dimensional analysis. How we do it? You see, force depends upon three factors. Your solution. Force depends upon three factors, that is mass, velocity, and radius. You write, let F is directly proportional to m to the power a, F is proportional to v to the power b. You don't know what is the relation of F with m, so we write F is directly proportional to m to the power a, F is proportional to v to the power b, and F is proportional to r to the power c. Now combining all, we can write F is proportional to m to the power a, v to the power b, r to the power c, or F is equal to some proportionality constant k, m to the power a, v to the power b, r to the power c. You take it as equation 1. Here you write where k is proportionality dimensionless constant, that means k has no dimension, and a, b, c are dimensionless constant. Dimensionless constant. You remember, k has no dimension, a, b, c has also no dimension. All are dimensionless. Now what will we do? Now we take the dimensional formula of physical quantity on both sides of equation 1. Taking dimensional formula of both sides in equation 1, we get, here it is your force m1 L1 t to the power what? Minus 2, that is equal to, you know, k has no dimension. Here mass has a dimension m to the power 1 whole to the power a. Velocity has a dimension L to the power 1 t to the power minus 1 whole to the power b, and a radius. Radius is a length, so it has a dimension L to the power c. So we can write m1 L1 t to the power minus 2 is equal to what? You can write m to the power a. You see L to the power b and L to the power c. We can write L to the power b plus c. Here t to the power minus 1 to the power b, that is equal to t to the power minus b. m1 L1 t to the power minus 1, this is your LHS, and is RHS we have m to the power a, m to the power a, L to the power b plus c, and t to the power minus b. Then you write, you remember, by principle of homogeneity. What is principle of homogeneity? When LHS, the dimension of LHS is equal to dimension of RHS, then the corresponding power of the physical quantities are same. That means here m is equal to 1, here m is equal to m to the power 1, it here m to the power a. You write by principle of homogeneity. Homogeneity means when dimensional formula of both sides equation are same, then the corresponding powers of the physical quantities are same. Principle of homogeneity, we can write A is equal to 1. This is your, here it is your equation 1, here you give equation 2. Here B plus C is equal to 1. This is your equation 3 you give, and minus B is equal to minus 2. This is your equation number 4. Just you give equation, name of the equation. So from equation 2 we get A is equal to 1, and from equation 4 we get B is equal to 2. We already get A and B, then how can we get C? From 3 we get 2 plus C is equal to 1, because B plus C is equal to 1, we get 2 plus C is equal to 1, C is equal to minus. After getting these A, B, C, putting these values in equation 1, we get F is equal to K, your M to the power 1, L to the power, your V to the power 2, and R to the power minus 1, or F is equal to, we get K M V square by R. This is the relation. That means we can write F is directly proportional to mass, F is directly proportional to square of the velocity, and F is inversely proportional to radius. And the total relation is F is equal to K M V square by R. You don't change K, you just write K, and because K is a dimensionless constant, proportionality dimensionless constant, you just write F is equal to K mv square by R. This is the relation. This is the question, first question. I am doing another question, that is question number 2. The time period of a simple pendulum T depends upon its length L and acceleration due to gravity G. Find the relation of T with L and G by dimensional analysis. You see, this is a pendulum. Suppose its mass is equal to m. This pendulum rotates from point O. It rotates from, this is its length. So, according to question, the time period of a pendulum, what is time period? Pendulum starts from this is the mean position, to this position, again come to this position, and again come to this position, and again to mean position. These are two extreme position, and this is the mean position. You see, the time taken to complete one vibration, that is m to this point, again from this point to m, again from m to this point, and from this point to m. This is called one time period. So, time period of a simple pendulum depends upon length L and acceleration due to gravity G. Now, we find the relation of T with L and G by dimensional analysis. How can we do? Like this. Let T is proportional to L to the power A and T is proportional to G to the power B, because it depends upon two physical quantities. So, we write only A and B. Or you can write T is proportional to L to the power A, G to the power B, or T is equal to what? Some proportionality constant K into L to the power A into G to the power B. You give this as equation 1. You write like previous case, where K is proportionality dimensionless constant and AB are dimensionless constant. Now we take dimensions of a physical quantity on both sides in equation 1. You write time period as a dimension m0, l0, t1, that is equal to your k. K has no dimension. So, L has a dimension L to the power A, G has a dimension L1, T to the power minus 2 to the power B, because it is an acceleration. So, you can write m0, L0, T1, that is equal to what? L to the power A plus B, L to the power A, L to the power B, and T to the power minus 2B. by homogeneity, here m to the power 0, here m is also absent. You don't think about power of m, you just write, consider the power of a length. Here a plus b is equal to 0, this is your equation number 2, and minus 2b is equal to 1, this is your equation number 3. From 3 we get 2b is equal to minus 1, b is equal to what? Minus 1 by 2. Putting b in 1, when b in 2, we get a minus half. You see, a plus b means a minus half is equal to 0, a is equal to half. Putting a and b in equation 1. Putting a and here b is equal to minus 1 by 2 and a is equal to 1 by 2. You will get fraction also. You can get. From 1, putting these in equation 1, we get t is equal to what? K, L to the power a. L to the power a means L to the power half into g to the power b means g to the power minus half. We can write k L to the power half by g to the power half. We can also get t is equal to k root over of L by root over of g, or t is equal to k root over of L by g. This is the relation. That means time period is directly proportional to the square root of a length and inversely proportional to the square root of acceleration due to gravity. This relation we get by dimensional analysis. I am giving one problem. What is the dimensional formula of mass taking force, velocity and time as a fundamental quantity? You know force is a derived quantity, but here you take force as a fundamental quantity, velocity as also fundamental quantity, both are derived, and time is a, and also time, because time is a fundamental quantity, here you take time also. How you do it? Solution. You know, according to Newton's second law, force is equal to mass into acceleration. You take mass is equal to what? Force by acceleration. Or mass is equal to force by, this is your what? Velocity by time. You can write acceleration is equal to, that is f is equal to f into t by v. That is equal to what? You can write force, velocity and time. This is your force to the power 1, v to the power minus 1 and t to the power, t means time, you take time, it's bigger quantity, as a, you take capital letter for time, time to the power 1. This is the dimensional formula of mass in term of force, velocity and time, taking these as fundamental quantity. This is question. Question will also come like this. What is the dimensional formula of mass taking force, velocity and time as fundamental quantities? You just like this, you write this Newton's second law of motion, that is F is equal to ma, or m is equal to f by a, or m is equal to force by velocity by time. You write m is equal to force into time by velocity, that is your f1, v to the power minus 1, t to the power 1. So, for today, we completed 2 applications of dimensional analysis, and we do some problems, simple problems. In the next class, we will go to 3rd application. So, if you like my teaching, please subscribe my channel, share my channel, so that I will be motivated to give you better and better video. Please subscribe my channel. for today. Thank you everybody.